All right. Now, the good news about this sheet is that these three problems are going to be a little different from what we've done, but we have done them before is what I mean. So let's just kind of talk through them. Now, in the top left-hand corner, what do you see? No. Top left-hand corner. Top left-hand corner. AP Chemistry. So you're doing an AP Chemistry worksheet. Okay? So I'm just trying to explain to you that this is all possible. You just kind of have to read it a little bit differently. So the question is, how many moles of magnesium are necessary to react completely with 50 and a half moles of oxygen gas to form magnesium oxide? Now, anytime we do a stoichiometry problem, what is a minimum? A balanced equation. See if you can write the balanced equation for that reaction. See if you can write the balanced equation for that reaction. Alright, so when you're reading through this, guys, y'all listen please. How many moles of magnesium of magnesium are necessary to react completely with oxygen gas to form? So that's all your words. So we know that we have magnesium plus oxygen gas, which looks like what? O2, to yield magnesium oxide. Now, what are your charges for both of those? 2 plus and 2 minus. They're going to cancel, leaving you with MgO. Now, if you didn't check your charges there, you might have gotten lucky, but just because they cancel. But in this case, they do. So, is it balanced? Nope, I need a what? 2, 1, 2, right? All right, and then it says, how many moles of magnesium? So there's our question. So how many moles of magnesium are necessary to react completely with 50 and a half moles of oxygen to form magnesium oxide? All right, so there's our reaction. So I'm going from oxygen to magnesium. Is this a limiting reactant problem? Why not? There's not two given amounts. Do I know where I'm starting and where I'm going? Yeah, I don't have to worry about anything else but those two things. I have no data about MgO. So in terms of the stoichiometry, it means nothing. It's just there to be a part of it. I need it to make sure I have a balanced equation. Now, what unit am I going from and to? Y'all like multiple problems? They're very easy. Okay, so I've got 50 and a half moles of O2, and I know that moles of O2 has to go on bottom so I can algebraically cancel it off. But how do I get from O2 to Mg? At what stage do I convert? Am I already there? Yep, I'm already there. So I can go from moles of O2 to moles of Mg. Now, where does the mole-to-mole ratio come from? Very good, the coefficient. So what's my top to bottom ratio? Very good, 2 over 1. Now, how many sig figs do I have in my answer? I've got 3, so I need 3. 3 am I given? I need 3 in my answer. What is 50 and a half times 2? Very good, 101. 101 moles of Mg. Now, so have I answered the question? Yes. I want to go one step further just to show you. You do not have to do this, but I just want to show you if you had to actually have the mass of this. It's 101 times 24.31. And the reason I know it's times is because moles is on bottom, grams is on top, right? So 24.31. That would make me have to have 2,455 grams of magnesium. Is that a lot or a little? That's a whole lot of grams of magnesium, okay? So just kind of showing you how these things work. So, but the final correct answer is 101 moles of magnesium. Okay? So that's problem number 1. Number 2, calculate the number of moles of the only precipitate, calcium sulfate, that will be formed in the double replacement reaction where excess calcium nitrate reacts with 125 grams of sodium sulfate. Sodium nitrate is also formed. See if you can write the balanced chemical reaction for that. Okay, so when we do this, it says calculate the number of moles of the only precipitate calcium sulfate, and then notice what it says, that will be formed. So what does that tell you about calcium sulfate? That will be formed. It's a product, okay? Now, calcium's group 2, what's sulfate? 2 minus, so I just have CaSO4, so that's one of my products. That will be formed in the double replacement reaction when, when calcium nitrate, all right, so calcium is Ca2+, wow, that's way too low. So I have CaNO3 reacts with 125 grams of sodium sulfate. So I have Na2SO4, correct? Now, if I just showed you this, could you predict what the other product was? Okay, what two ions are left that are not already used? Sodium and nitrate. But what's the good thing? The problem tells us that sodium nitrate is also formed. So you can do these kind of problems even if you don't have the products listed, okay, or all of them listed. All right, so here's what I have. Is it balanced? What is it? The 2 in front of an ANO3, right? That's all I need. All right, and then it says, so let's kind of look at the problem now. It says calculate the number of moles. So I know that I need moles of calcium sulfate. So here's my question. I need moles of that thing. That will be formed with a double replacement reaction when, and this is the word I want you to circle. That needs to be very exciting to you. As soon as they tell you something is an excess, what does that automatically make the other one? The limiting reactant. This part right here is very good because as soon as it says calcium nitrate is in excess, that automatically makes sodium sulfate the limiting reactant. What if they had not told you calcium nitrate was the excess? How would you have known? Do they give you any numbers for it? Well, if they don't give you any data, then you can't use it. Does that make sense? The only other thing they give you data about is sodium sulfate, which is 125 grams of sodium sulfate. So now, I know my limiting reactant. So can I convert from my limiting to my unknown? Okay? What unit am I going from and to? Grams to moles. How many steps? 2 steps. So, I'm starting with 125 grams of Na2SO4. By the way, that green number up there that I wrote by the problem, that's the molar mass. I went ahead and calculated that. So I've got grams of Na2SO4. But what's the first thing I have to convert to? Moles. I've got to go to moles first. So moles of Na2SO4. And then moles of Na2SO4. So unit-wise, I know what cancels. But what's got to go on top? Very good. Moles of calcium sulfate. Can I stop right there? What's the question asking me for? Moles of calcium sulfate. So can I stop? Yes, I'm done. This is what the question was asking me for, so I can stop right there. Now we just need numbers. Anytime you see mole and gram, what does mole get? A 1. I've already calculated the molar mass. It's 142.04. And then your mole to mole comes from where? Coefficients. What is the mole to mole right here? 1 to 1. Very good. So now, what's the only thing I have to do in the calculator? Divide. So somebody run those numbers for me. Hang on. Tell you what. I want to write these down for a reason. This is what shows up in the calculator: 0.8800337933. So I need 3 sig figs. What number do you start counting with? Start counting with an 8. So 1, 2, 3. Look right there. So what's your final answer got to be? 0.880 moles of CaSO4. A lot of people want to leave that 0 off. They're like, that 0 doesn't make any difference. you're right. It technically does it, but it's making it more accurate. Yeah, everybody good on that? Okay. Let's look at the next one. See if you can write the balanced equation for that reaction. Okay. All right, so we need a balanced equation. So it says calculate the mass in grams of gold-3 nitrate, and you have to read how it's worded. That will be needed to react with. So that tells me that gold-3 nitrate is a reactant. What is the symbol for gold? All right, so AuNO3 will be needed to react with excess. Aren't you excited about that word right there? Yes, no limiting reactant. All right, that automatically tells me that gold-3 nitrate is my LR. Needed to react in excess with calcium hydroxide, so CaOH2. Now, what type of reaction? Double replacement. Could you figure out the rest of this if that's all you have? Yeah, this is really easy. So what we have, but it actually tells you, so we have the only precipitate gold-3 hydroxide, which is AuOH3 plus calcium nitrate, CaNO3 2, and I'm cramming that 2 in way back there. Now, you'll see a lot of 2, 3, 6 rule in this. So I've got 3 there, so I need a 2 here, 2 there, I need a 3, 3, I need a 2, 2, I need a 3. So 2, 3, 2, 3. Now, when you read this problem, did anything about the data jump out really weird to you? The kilograms part. So we've got to worry about the kilograms. We've got to be able to figure out how to make this happen. I'm going to show you 2 ways to do it. Whatever way you want to do it, I'm going to show you 2 ways. But first of all, let's look at our question. Calculate the mass in grams. So here's my question. I need so many grams of gold-3 nitrate needed to react with excess calcium hydroxide. There's a word missing. That produced is really what it should say. That produced 4.75 kilograms of gold-3 hydroxide. So there's 2 ways to do it. First of all, hopefully you guys remember what that little acronym is for the metric system. King Henry died drinking chocolate milk. So they give us 4.75 kilograms. Now, we can't use kilograms because everything we do is in grams. So how can I get from kilograms to grams? Okay, 1, 2, 3. I've got to move it 3 times which way? To the right. So 1, 2, 3. Now what's going to go into that empty bubble? 0. So it's going to be 4,750 grams. You can do it that way. I'm going to show you how to include this step in the stoichiometry, just so you can see it. Okay? So I've got 4.75 kilograms. Now I'm going to leave out the formulas for this one just for this first part. So I've got kilograms to grams. I can do this. Remember we did this a long time ago. So the first thing we ever did. Now, you've got to know how those units match up. Where does the 1 go? In one blank, there are a blank. Yeah, that's a bad way to think about that. In 1 kilogram, there are 1,000 grams. Okay? Either way you want to do it, works perfectly fine. Because if you multiply that 4.75 times 1,000, what are you going to get? 4,750. It's the same number. This is just showing it in the stoichiometry. If you want to leave this step out, that's perfectly fine. So now we're just going to continue like we always do. But we're going from what unit to what unit? Gram to gram. So we need, now I'm going to go ahead and plug all those in. So I've got grams of, where do we start? AUA, I promise I'll get out of the way in just a second. So moles. Yeah, I've got both of the masses up here. we started, yeah, see, I left that out, of AuOH3. Sorry, I left that out from that whole first part. So we're going from kilograms to gold-3 hydroxide to grams of gold-3 nitrate. The setup should look understandable, and I know I kind of slopped that mess up there. All right, which part? Which number, which parenthesis? First, second, third, or fourth? Okay, that's grams of AuOH3. Yeah, because we're going from grams to moles. Remember, the only time you can convert from one compound to the other is where? The mole-to-mole step, which is where we convert it in the middle. So actually the fourth step, this is our mole-to-mole. Right there in that, it's actually the fourth one this time. Excuse me, the third one, not the middle one. Just because we included it, the conversion of kilograms to grams in stoichiometry. So nothing is different about this problem except for the initial. We just changed from kilograms to grams. Everything else stays the same. Now, anytime you see a mole with gram, what does mole get? A 1. 1. What is your mole-to-mole ratio? 2 to 2. What is that? Why is that good news in your calculator? Skip it. Get rid of it. And I've already given you the masses. So the mass of gold-3 hydroxide is 248.0, and gold-3 nitrate is 383.0. So 4.75 times 1,000 times 383, all divided by what? 248, and that's it, right? That's a simple, what's this thing doing? All right, my calculator is fixing to die, so it will not give me the answer. Somebody give me the answer in 3 sig figs, please. How much? That's right. 7,340 grams of AuNO3. 7,340 grams, which is a lot. It's a whole lot. Okay? So 7 kilograms, which is a lot. Okay. All right, we're going to do one more problem. And this one involves a limiting reactor. In what? Okay, every time we did this problem, do you notice you had one piece of data and there was one question? What you're going to see next is you're going to see 2 pieces of data and one question. So you've got to figure out what to do with that, with those 2 pieces of data. All right, so if you'll just turn over. Now, so if you will notice, look in the very top left-hand corner. What does that say? This is Auburn. So if you plan on attending there, you're actually going to see one of the problems that you will actually do. Okay. So, but what I'm trying to prove to you is you're in high school and you're fixing to work a problem that they work in college at Auburn. So you are able to use the material and the knowledge that you've gained here to be successful in a place like this. I promise. Okay. So a 2-gram strip of zinc metal is placed in an aqueous solution containing 2.5 grams of silver nitrate. So, all right, so we know that we have 2.00 grams of zinc, and we have 2.50 grams of silver nitrate. The reaction is, and then here's the question, and for some reason it's left out, but we need to ask this. How many grams of Ag are produced? Okay, so that's our question. How many grams of silver would be produced? All right, Tanaya. So you asked the question a minute ago, how do I know if it's limiting a reactor or not? So this time, how many gibbons do I have? I've got 2. Which one of those do I pick to convert to the silver? That's what people always say. You pick zinc because it's less. You have to find the what? The LR, which is the limiting reactant. Now, the problem with the units that they've given us is they've given us the units of what? Grams. But can you compare grams to grams? No, that's the problem. So here's what I want to do. There are 3 steps to solving for the LR. That's fine. Alright, so step number 1. And this isn't a step you always have to do. It depends on what the units they give you in. So convert grams to moles. Haven't we always done that? Okay, that's an easy one. And you may not have to do that. If they give it to you in moles, you can skip right to step 2. Alright, convert moles of reactants to moles of unknown. What is it called when we go from moles of something to the moles of the other? That's our mole to mole ratio. We've already done that. In this problem, the silver. Does that make sense? Because they're asking about silver. How many grams of silver? But we're not going to grams yet. We're just going to what? According to our steps, we're going to moles. Okay? And then the third step, you don't have to do anything, but you just have to identify. So the LR is equal to the least number. But the key is, what does LR stand for? It must be a reactant. So many times I get people saying the LR is a product. That makes no sense. That would be called the limiting product. This is called a limiting reactant for a reason. What? What'd you say? You would be surprised. You would be surprised. Alright, so the problem with these that people get aggravated with is once you notice it's the limiting reactant, it's the easy part, but the hard part that's aggravating is that you have to do everything that we've always done twice because you have to convert both reactants grams to moles. And I get it, that's aggravating, but this is the only way that's possible to be able to perform these problems. So, we're going to start with 2.00 grams of Zn, and we're going to start with 2.5 grams of AgNO3. Grams of zinc to moles of zinc. Grams of, Nick, will you do silver nitrate for me? Never mind. Yeah. Say it for me one more time. What's the zinc? Point what? Okay. All right, let me step back on me. Is anything different about what we've ever done before? No, it's just doing it twice. That's all the difference is. We just have to do it twice now. We did this last week. Yes. The back page, the back of the first page. Everything was kind of the same stuff, but just local problems. We're going to do that today. We didn't do that. But we're going to do that today, too. I'm going to cover theoretical today. Because those other 2 problems you couldn't do theoretical with, I'm going to show you why. Yeah. No, you couldn't do percent yield because they didn't give us actual. And I'll explain all that. Yes. The last problem, part C. Alright, whoa, my calculator is dying. I'm going to have to rely on y'all. Alright, so how many moles of Zn do we have? Yes. I'm good. Just, how many moles of Zn? Alright, how many moles of silver nitrate? 0.147. I remember that number from earlier now. Alright, so that's all step 1. Okay? Every bit of that is step 1. There's nothing different that we've ever done except we've done it for both reactants. Yeah, just divide it. Okay? Yeah, now next step is convert the moles of the reactants to the moles of the unknown. Now, what is the unknown? Silver. All right, so this is the easy part because all it is the mole to mole ratio. All right, so what is your mole to mole ratio from silver to zinc? 2 to 1, very good. And what is it from silver to silver nitrate? 2 to 2. So what does that change about the bottom value? Nothing. 0.0147 moles of Ag. And then somebody double that top one for me. Yeah, I can. 0.0620. I wasn't paying any attention to what it was, to be honest with you. All right, so there's our moles of our unknown. Now here's the phrase: you can only produce as much. Hold on, I just messed that up. The least amount is made is the most that you can produce. I know that's weird. The least amount that is made is the most that you can produce. So what is the least amount that is made? The 0.0147. So that is the most that we can make. So which reactant is going to limit our reaction? Silver nitrate. So that tells me that silver nitrate is my limiting reactant. Does that make sense? So again, because this number is the least, so since this is the least, that means this is the LR. Does that make sense? Why can't we make 0.062 moles? Because you don't have enough of the other one, right? It's not going to allow you to make that much. All right, so that's what the limiting reactant is. So now let's look at part B. Part B. What is the theoretical yield? Now we got to talk about this. What in the world does theoretical mean? In theory. What does in theory mean? All right, so let's actually pretend that I really did give you 2 grams of zinc and 2.5 grams of silver nitrate, and I said, go do this reaction. In theory, theoretically, you should be able to produce a certain amount. Basically, how you calculate the theoretical is what you do on paper. Okay? So theoretically, if I did this in a lab, this is how much I should get. You all should get 100s on all of your tests in theory, right? But does that always happen? That does not actually happen. So we're going to talk about that in just a second. But theoretically, this is what you should be able to get. Now, the good news is, it says, what is the theoretical yield in grams of silver? Well, what's the good news about this part? What do you already have calculated? You've already got the moles of silver. So what was your least value of moles of silver? So this turns into a one-step, very simple, 107 point what? Silver was 107.87. Well, that's easy. This is why we convert from our LR to our unknown, is so when we get to this part, it's an easy one-step problem. You don't have to do anything else. This makes it so much simpler. So again, this was from the LR. That was where we got that value. That was from the limiting reactant. Okay? Well, I need a value. I need an answer. What's the answer to this? Okay? 1.59 grams of Ag. So, this is what we should theoretically get. So that is like making 100 on our test. If we did the lab, if we got that, and we got 1.59 grams of silver, you did it perfectly. Everything you did was flawless. But, just like we know, just like in tests, labs aren't always perfect. So C, if you perform the reaction and make 1.37 grams of silver, what is your percent yield? Before I talk about percent yield, I want to talk about something else real quick that ties into it. If we go to the store and they're having a sale, how do they always promote sales? Percent off. What does the basic definition of percent mean? So, if you walk into a store and let's say the shirt is $60, where would that go? That's the whole price of the shirt. Well, we're having a 30% off sale. So we know the 30%, we know the $60 for a shirt. What are you missing? The part that you're going to be able to subtract from the total value, right? So you can do a little bit of math and you can figure out, all right, well, this is how much I'm saving. So that's how percentages work. Just like we talked about with this percent yield. So here's the difference. So percent Y, and I want you to write this down somewhere on that bottom part. Percent Y, let's talk about it out loud. What is the whole value? What should you be paying for that shirt? What should you be producing in the reaction? Okay, what is that called? No. What should you be getting? So that's technically how much we should be paying, right? But what do you actually pay? So it is actual over theoretical times 100. And I've got an even easier way to remember it. It's what you got divided by what you want. I got how many grams when I did the lab? How many? 1 point what? 337. What did I want? I wanted 1.59. It's what you got divided by what you wanted. Okay. So when we go back and we do this, so again, percent yield is actual over theoretical. The actual was 1.37 divided by 1.59 times 100 gives me what percent? 86 point what? Did you do a good job? If I told you right now you had 86 on this test before you ever took it, would you do it? Would you? Some of you, that's not acceptable. Some labs, that's not acceptable. Some labs, that's outstanding. So it just depends on what lab you're performing and all those things that go into it. But that is a good percent. Most labs yield 70% or higher. You've done a really good job. 70% or higher is your goal on labs. And so this is how it works. And this is it, guys. This is the extent to what you're going to be testing. There's one more thing we're going to talk about tomorrow, or Friday. And it's how much excess reaction remains. But other than that, it's just a quick 3-step conversion and you're done. So any questions on this? We're done with stoichiometry other than that little thing. We'll review on Friday. Plan on testing next Tuesday.